Hello everyone and welcome back to eCoreAcademy. My name is Anita Raj and I'm going to be teaching you Java today. Our lesson is going to be starting our second unit, which is all about conditionals. It's actually our third unit if you include our introduction and installation as one unit. So my correction, it's going to be our third unit and it's going to be on conditional statements. We're going to intro this unit with everything about if statements, and essentially if statements are fundamental to understanding really the basis and the basics of conditional statements. And conditional statements pretty much bring in a new facet of coding. And this coding is not so much based on a chronological order of set steps the computer has to follow no matter what input is put in by the user. Instead, now we're kind of shifting our approach into a more decision-based branch structure of code. So based on the decision the computer makes, it's going to follow these different pathways. So it's very like it says in the word conditional statements, it's very conditional based. If a certain condition is met, something happens. So that's what we're going to be looking at today. Before I go into Eclipse, I'd really appreciate it if you all could like, subscribe, hit the post notification bell, comment, and share. Let me go right into the lesson now. Okay, so here are the basic notes on if statements that we need to understand. I've typed them out in the comments here in Eclipse. So here's just a new unit introduction on our conditionals unit. And I want you to just think about the fact that some problems that we are trying to solve with our code cannot be solved using chronological events. Chronological events mean code that is written in a step-by-step process. That means that it's like going down a laundry list. Each task is just executed in a certain order, and there's no straying away from that. There's no exceptions. No matter what the input is, the same a set of tasks are performed. And sometimes that doesn't work. So the computer needs to make a decision on what to do based on the information it is given. So we might be given a set of information, and following this series of steps might not necessarily work for a given circumstance. So given this information, the computer then has to have the intelligence to decide what alternate route might I take with the code I've been given by the programmer. And that's where conditional statements come into play. So certain conditions and structures need to be established that help the computer decide how to execute a task. So if the computer is given some kind of input from the user or another algorithm or system, we as the programmers have to establish some kind of system, some kind of structure where certain conditions have to be established. Like, if this is true, then do this. If this is false, then don't do this. That we need to kind of make very specific instructions for the computer to follow based on the varying input it might get. So for each condition, there may be a specific and different response the computer must make. So there might be different exceptions for different scenarios, so we have to account for those different exceptions. Following one set series of steps might not work for every input we're given. So the computer needs to be able to produce a unique or a different response for each input. We call this branching because there's different possible pathways the computer can take to creating an output, all depending on that initial inputs it was given. So that's where conditional statements come into play. They help us choose which statement to execute next. So conditional statements help us choose which statement to execute next. You can think of it as if-then logic statements. So we use if-then logic statements when it comes to hypotheses in science. If an event occurs, then this is the outcome that I'm going to predict. That's the same way that conditional statements are structured. If this is the input that I possibly get from a user, then this is what I want the computer to do. That's a conditional statement, and because we emphasize so much on the if, it becomes an if statement, which is the name of this lesson. These conditional statements are like a flow diagram. They can branch off into multiple directions, and once they branch off, then the computer knows exactly what the next tasks it must execute are. So these tasks, by branching off, it modifies how the code is executed. So if a specific input is given, then we might go down pathway 1. If another input's given, we might go down pathway 2. So it modifies which code is actually active, which code is being used in generating an output, which might vary depending on the input we're given. And this is in the form of if statements, like I just said. The evaluation below is done. So I included this evaluation just so you know exactly what the logic behind if statements are. So if a specific condition is met, so it's true. For example, maybe the user had to enter their favorite color, and the condition was that the user entered red, and let's say the user did enter red, that means that condition is met. It is true. It's supposed to say is met, then the code is executed. So if that condition is true, if the user entered red, then whatever code is underneath that if statement, that's the block of code that's activated in generating an output or a response. If a specific condition is failed and false, meaning let's say the user did not enter the color red, well then the code in that block underneath the if statement that reads if the color is red is inactive. It's not executed. A different branch or a different pathway may be taken depending on the input we were given, because the input was different from what that if statement was looking for, and the condition the if statement wanted you to meet. So then I also wanted to go over rational comparison / relational operators. So these operators essentially ask us a question, and then they will compare data values for us to give us an answer. So operators, you may remember, have to do with math, but in this case, we're not actually doing like math operations. We're really just comparing two data values we're given. And usually these come in the forms of integers and doubles. So we use the greater symbol to imply greater than, the less than symbol to imply less than, greater than or equal, so you would just type the greater than sign and then the equal sign right next to it. So these two symbols together symbolize greater than or equal to. When we commonly write it in math, we usually do the greater sign and then a little bar right underneath it, but here you're going to have to write these two symbols together, and the same thing for the less than or equal to. If you want to say equal to for numbers, you have to write two equal sign. And here's where the distinguishing factor comes. If you write one equal sign, that means you're assigning a value to a variable. So if you have a variable called number and we put an equal sign and we put 5 after the equal sign, that means we're saying the variable, we're giving it a new value. We're assigning it a new value, and that value is 5. However, this double equal sign up here is a question. It's asking. If we said a number equals 5, we're asking, is the value stored in number, whatever it may be, is that equal to 5? Means if a variable equals something without changing it. So we're asking, it's like a question, like I said up here. We're asking the question, is this variable equal to 5? We don't know. We're asking the question, but essentially we're not going to change what the value in that what's the value stored in that variable is. So again, double equals is like a question. It's not changing the original value of the variable like the regular equals is. If you put dot equals, you're doing the same thing as equals, but you're doing this for strings. So strings, remember, are like a series of characters, so like words essentially. So we can't put equals for strings, we must put dot equals for strings. If you put an exclamation mark and an equal sign, this means not equal to. So as long as a number or something is not equal to a certain value, then a condition is executed. If this exclamation mark equals is put into an if statement. So all of these relational operators reply false or true to the conditional, so the code knows whether to execute a step or skip it. So if we compare two values, if we ask our computers, is 5 greater than 3, and the answer is true, then maybe the code underneath that if statement is executed. If it's false, it's not executed. So that's what these operators help us determine. I also included an example down here of an if statement, and I kind of wanted to show you how it works before we go later on into actual exercises where I'm going to write this code with you. But here we have a question the computer is asking, what did you score on the exam? The computer is asking for input from the user. What did you score on the exam? And we are going to record whatever number the user inputs into the variable score, which I declared up here. And I also imported keyboard reader because we're getting input from a user. Now we're doing these if statements. There's two if statements here. There's one up here and there's one down here. So there are two if statements. And this if statement essentially reads, if I just said it in our language, if the score that the user entered, we don't know the score yet. This is just the variable. So essentially, when the user enters an actual numerical data value for the score, it's going to be compared right here where the variable is. This variable is almost like a placeholder. If the score the user enters is greater than or equal to 65, 65. So essentially we're asking, with this relational operator, we're asking, is the score the user entered greater than or equal to 65? If this is true, if the score is greater than or equal to 65, then this block of code right here will be executed. This computer will print out great job, meaning the user passed because they got over 65, which is the failing grade kind of demarcation. However, if this isn't true, if the score is below 65, then this if statement will evaluate to false, and the code in here will be skipped. It's not going to be activated because this evaluated to false. When this is skipped, it will come down to the second if statement if the score is less than 65. So this is accounting for the scenarios that are not covered in the first statement. This is assuming the score is over 65. This is the possibility that the score is below 65 and failed the first if statement. If the score is below 65, then and if that evaluates as true, then this code will be activated, do better next time. So I'm just going to run it for you, and you're going to see it in the console window. Just give it a second. What did you score on the exam? So let's say I say I got an 80 and I hit enter. Great job. If I run it again and then I say what did you get on the exam, and I say 65, great job, because we said greater than or equal to. Lastly, if I put a score like a 40 and I hit enter, do better next time. So it takes the values I entered, it stores them in score, and then it compares them to the if statements, and it evaluates to true or false to determine which code it's going to execute, or what in this case, what print statement it's going to actually print. So yeah, that's pretty much it for if statements. And that's it for the lesson. I hope you enjoyed. If you did, please make sure to like, subscribe, hit the post notification bell, drop a comment down below, and share using your socials. Our next video will be all about else if statements and ladders, and I hope you join me for that as well. Bye.